to be very quiet here. He's very shy. Hi, Mario.
Hi, Stuart. How can I help you? You appear to have a lot of visitors today.
Yes, I do, and I would like to show them how useful you are.
You look very happy. Would you like me to call your friend?
Yes, please.
Okay, dialing him now.
Hello, Dave.
Hello, Stuart. How are you?
I'm very well, thank you. And you?
I'm good. Would you like me to tell you a little bit about Mario?
Oh, yes, please, because remember, I'm an old guy with dementia.
Well, he'll be able to take on many of the roles of a human carer for a fraction of the cost. He can help keep your mind active, for instance, by playing games. He can ensure that you stay safe. He will follow you around the house, detect if you need medical assistance, and make sure that you're taking your medication or even call for help.
Yes, and indeed he can also perform facial recognition, and in future he'll even be able to use facial recognition to detect mood from facial expression. So whether I'm happy or sad or confused, as I obviously am at the moment. So anyway, it was good to talk to you, Dave. Take care.
Thank you. Bye-bye.
Bye.
Stuart, a reminder, it is time for your favorite program.
I like this bit.
Do you know the business opportunity for digitalization of healthcare in Western Europe will be worth $72 billion by the year 2026? Please help me to show how 5G will support the development of the home care robotics industry.
Okay, yes I will. So I would like to introduce you properly to my friend Mario here. He's actually the result of a collaboration in an EU Horizon 2020 research project. The collaboration involves partners from UK, Ireland, Italy and Ireland. We have some representatives here from the collaboration. I'm sure they would be happy to talk to you about the project in more detail. Now, the video that you saw there gives some indication of some of the things that Mario can do today. The primary focus of what he's trying to achieve is to give companionship, mental stimulation and engagement to dementia sufferers, because it's found that that's really what's necessary to sort of stave off the effects of dementia. But he's actually capable of so much more. So if you sort of think about it, we alluded to some of that in the conversation I had with Dave. Using facial recognition, for instance, we can start to use things like non-verbal cues to determine a state of mind or a state of health. We look to move towards far more naturalistic interactions with speech, and perhaps even get him to say digitalization properly. But then we can look at other things. We can integrate him into the IoT ecosystem. So for instance, if you have a home alarm system, you can connect Mario to sensors that detect, for instance, when the window is left open. So perhaps get the patient to shut the window. If he had arms, then maybe he could shut the window himself. Also detecting, using medical wearables if there is a need to call for additional medical assistance. Operating, not just allowing me to watch my favourite programme on Mario's small screen, but what if he can actually control the TV and home entertainment system himself? So there's all sorts of additional things that Mario could actually be doing to enhance his current capability. But there are certain limitations here. If we really want to be able to get Mario into individual homes, then he has to be designed to a cost. Also, we find as we put the additional complexity into Mario, it's going to have an impact not just on that cost, but also on the battery life. And one thing that's really important is that the sort of duty cycle of the robot has to be aligned with the behaviour of the patient. So Mario has to be active all of the time that the patient needs to be mobile. Right now, if he's following a patient around the house, maybe we can expect to get 2 to 3 hours of life out of him before he needs to go for a recharge. So this is where moving some of this application capability into the cloud comes into play. So we can, by doing that, greatly enhance the capabilities of the robot, but again, doing that in a way that manages the cost. Now, to give you an idea of the kind of processing that we would need to move into the cloud, in order to navigate around its environment, it's actually processing something like 10 gigabits a second of video information. You can imagine transporting that into the cloud using something like Wi-Fi or LTE. It's not very reliable. So you need the low latency, high throughput capabilities of 5G in order to be able to support that. So if we have a look then at sort of the roadmap of capabilities that we can see potentially enabled by 5G. So today, the navigation that Mario performs is very much two-dimensional, using LiDAR. He's got some laser sensors on the front, but we can move towards complete 3D mapping of its environment, and moreover, make it dynamic so that when things change, then it can very quickly detect that and adjust its behavior accordingly. Moving from basic telepresence to being able to have a fully integrated communication suite on board enabled by technologies such as WebRTC. Moving from basic speech interaction to fully naturalized communication, so that it can actually detect the nuances of mood in person's voice and not just what the person is trying to say. And then adding to that all of the non-verbal cues as well. And then moving from isolated web applications to having a fully integrated capability to integrate as part of the Internet of Things with its complete environment, so all of the entertainment systems, the care systems, and so on. So these are all of the possibilities that we're looking for. This is a long way off and obviously requires more research, but really what I'm trying to convey here is the potential that is possible. Now, so talking of IoT, I'm actually wearing one of these medical wearables so that Mario can actually keep track of my health. So, hey Mario, please check my heart rate.
Stuart, you seem to be getting overexcited. Let me get some help.
I've had to sit down then. Thank you very much.